Up next, the 3:30 slot is Dr. Frank Witte, Changing the Solar System Economy Paradigm.
Thank you very much for having me here. I would like to start out with a question that I'm not going to answer, but a question nonetheless. And that is, ask yourself for a moment, or for a couple of moments, when were the Americas more valuable to the United Kingdom? In their first 100 years as a colony, or in their most recent 100 years as a trading partner and a security ally? I want to sort of briefly tell you something about who I am, and I want to tell you something about why I'm going to address this topic. I thought it would be a good idea to say a little bit about economics, perhaps most importantly of all, because I'm not an economist. I'm a theoretical physicist who turned rogue, turned to the dark side, and now is working in an economics department. And I want to say a few things about, say, economic models that I think are important when we discuss, say, the economics of Mars, Earth, the solar system, and these kinds of issues. And finally, I want to present to you with say, what an application of an economic model would look like. Not because I think it is something that you should sort of believe and take from here as in this lecture we heard this or we heard that, but as a starting point for how you could approach these kinds of questions from relatively standard economic models. Like I said, I'm a theoretical physicist. I've done my PhD in theoretical physics, and up until 2010 I was just your average theoretical physicist doing his theoretical physics research. Now, in a sense, I'm still that same average theoretical physicist, but I'm teaching in an economics department. I teach environmental economics and economics of science. And one of the things that comes up when you look at these subjects are problems about how do we define and how do we decide economic policy, problems that you actually also have when you think about, say, space exploration and how to convince people that it's worth paying for it. So I want to say a few things about economic models, because there are many things that can be said about it, but there are also many, I think, misconceptions about what they are. What economists try to do essentially is they try to tell stories about how the economy works, or how they think the economy should work, and they try to sort of constrain these stories by using mathematical models. It's very often not the case that these models are sort of intended to be very precise prediction, say, tools for what's going to happen tomorrow, next week, or the year after, but they are sort of tools to be able to creatively shape your thinking while at the same time being forced to sort of be relatively explicit about what your assumptions are, what the things are that should hold for the model to be valid, and to try and understand the mechanisms that drive our economy. Physics and engineering models are obviously very different. And one thing that I often say when I want to sort of make my economics students laugh is that I say, well, as physicists, when we find out that electrons aren't behaving according to the laws of nature, then we change the laws of nature, right? We say, oh, well, apparently we got that little aspect wrong, so let's change it. In economics, what you have is, if you tell people, this is an economic law, this is how people behave, everybody goes, I don't think so. Electrons never do that. So you have this, in economics, this complicated interaction of the discipline itself with the thing that it claims to study. And that makes things very hard. Where that comes up a little bit is the last bullet point under economic models, is you have this distinction between positive economics, economics that tries to describe what happens in the world, normative economics, the economics that tries to tell us what would be the best thing to do. And those are not necessarily the same thing, even although they might be using the same tools. A final point about economic models that I want to sort of emphasize is the issue about evolution in time. Economic processes are not constant, right? And in many sciences and engineering, say, disciplines, what we're used to is that let's say, as a discipline, we're very good at predicting what happens at relatively reasonable times. In economics, it's extremely hard to predict what happens in very short timescales. With some grain of salt, I would say it's very easy to predict what happens at very long timescales, because there we use concepts of equilibrium. And even when we might not always necessarily believe that the equilibrium actually really ever exists, but they are a very sort of useful tool in terms of thinking about what would happen in the long run. Roughly, what you can think of is in economics you have an equilibrium, you have a trend towards it, and you have shocks on that trend. As human beings in our day-to-day life, when we watch the news, when we look at the stock market, say, prices and these kinds of things, we tend to be very occupied with the shocks. But if you take a look at a graph of, say, estimated GDP from 2000 BC up till now, then the Great Depression and the Great Recession are tiny shocks in a very clear trend of growth. So long-term is sometimes easier than short-term. And that's something which, well, I sort of need to sell to you to say, if I want to talk about solar system economics, about something that would only be relevant in the long term, then, well, maybe that's a useful thing to do from an economic point of view. I thought it was really great in the previous talk that the speaker mentioned this mining paradigm of economics. We go to Mars because there's something there that we want to have. And how difficult it is actually to make that work as a viable, say, reason to do this. So the second step in thinking about economics in the solar system would be to say, well, we maybe, sort of with the colonial paradigm, maybe we can send people there to produce the stuff that we want to have. Right? There's still this aspect of they're doing it for us, but there's already something happening over there that might be relevant. The reason why I asked you that question earlier, and maybe I should say, I'm not British, so I don't care whether you think, say, or what you think about the UK and the usefulness of the relationship between the UK and the US. I'm Dutch. He gave you New York. No.
Thank you.
We can have a long discussion about how good that was for the Netherlands. But the idea that, say, as a trading partner, the US has been much more valuable to the UK than in its early colonial period. That, I think, is something which, on the one hand, sounds very sort of reasonable. At the same time, when you visit London as a tourist, you might get that impression that you often have when you visit a former imperial capital in Europe. There are all these grand buildings from the colonial era. So it must have been incredibly wealthy. What I often say to my students is, well, that's because all the shanty towns of the working poor have, of course, been removed. Right? It's only the buildings that were worth preserving that are still there. So that might make the impression that everyone must have been incredibly rich in that period, which, of course, most of the people were shockingly poor. That's different in London now. There are still, of course, poor people, but it's no longer on the scale that you saw, say, in the 18th century, 19th century. So if you think of trade, then obviously one sort of economic model that immediately comes to mind is free markets. And I think here it's important to say that free markets are not markets where nobody's doing anything. It actually takes an effort to make a market free. And I've listed a couple of things here which are relatively sort of standard economics reasons why markets might fail. Externalities, that's when the two people agreeing an exchange or agreeing a contract are agreeing something that has an effect on someone who's not part of the agreement. That will mean prices that are being agreed are not correct. They are not, say, reflecting all the benefits or not reflecting all the costs. That makes a market fail. It's something that happens a lot, say, in environmental issues. Informational asymmetries. If I, as a trader, know something about the goods that I'm selling that you don't, then I will use that to make you pay a higher price. Again, that is a reason why a market can fail. Risk is not necessarily a reason why a market can fail. Because if the good that I'm selling you is risky, you might go to an insurer, take out insurance, and cover your risk. Uncertainty, however, is a different matter. If the risk is not quantifiable, or if the risk is of a kind where you actually don't know what might happen, then it becomes difficult for a market to deal with that problem. Beliefs and rational expectations are such an issue. Very often when we think of free markets, we also think that everyone behaves rationally or has rational expectations about the future. But sometimes you encounter situations, actually quite often, where people don't. Where people think, for example, that you can always keep on building and selling real estate property. That will always get more expensive. And that will always generate profits. And that it will never happen that everyone collectively at the same point in time decides that this was enough and now it's going down. And of course these things happen. And what was also raised in the previous talk, valuation problems. In my economics of the environment class, one question that I always ask my students sort of in first class is, what is the value of a polar bear in the Arctic? And then I'm not thinking of it in terms of hunting it and selling it, but what is the value to you in LA that there is a polar bear in the Arctic? And in environmental economics, you very often have to answer these questions, even although it's very difficult to do so. The reason why I'm bringing them up here is because I believe that when we're talking about space exploration, the future benefits, the future costs, the current costs, all these factors play a role. So I think simply saying, well, probably just say letting it all up to the markets is not necessarily a good idea. So how do policy decisions come about? Cost-benefit analysis is the main thing. That requires, say, calculating these future benefits, which may be very hard or very shaky if you want. But one key aspect that I would like to sort of highlight is this notion of future discount. The basic idea is very simple. If I would offer each of you the choice of, say, getting from me $100 now or in a year from now, probably most of you would prefer to get it now. And that's just a very simple statement of the fact that if you can have a benefit now or, say, in a year from now, you prefer to have it sooner rather than later. And if I would offer you to pay a bill now or to pay that same bill in a year from now, probably you'll prefer to pay it in a year from now. So it's a very sort of human preference for how to receive benefits or make payments in time. But what that means is that if we weigh benefits, then what we tend to do is we tend to weigh future benefits less than benefits which are close at hand. In many cases, when we're talking about business propositions where, say, within 4 years your business has to start making money or these kinds of things, 4 years, that's sort of a time frame that's easy to oversee, but it's also a time frame where this discounting doesn't have such a huge impact. But if we're talking about time frames of 100 years or 150 years, we humans struggle. And I think it's really important to realize that we do. And I think it's also really important to realize that we are more and more encountering issues in our world where we have to find a way of overcoming that. Whether this is how to deal with climate change, whether this is how to sell to people that it makes a lot of sense to open up the door to the solar system as a place to do economic activity. These say that the way in which we discount is something that we decide politically or economically. Very often the rate at which we discount is when it's, say, drawn from financial terms, then it's very often an interest rate, something like this, or an expected, say, return to capital rate. But it is a political decision. And many of these, say, decisions need to take into account that if we talk about space exploration or climate change, we talk about something that affects generations rather than just a 5-year or a 10-year project that we're running. A similar thing is opportunity cost. The cost of something is never just what the thing costs. So the cost of a policy or of a project is never just the bare cost of that thing. It's also the foregone benefit of the things that you can't do. And I think what's important to realize is not every choice has the same, say, set of things that you then cannot do. And again, this is something that is common practice to make these kinds of cost-benefit calculations and to use this. But if it is spanning generations, then I would say it becomes an entirely different story. Because in a sense, the number of things that you cannot do if you don't do a certain development now just cascades and becomes bigger and bigger. What I think that what a common problem is that we have in many of our issues nowadays is that we weigh the benefits of the future too low. Or, in the case of climate change, we weigh the costs of future, say, damages too little. Now, what I was saying is I think the real value of the solar system as an economic space will come from trade. And I'll go through some of these slides a little bit quicker because the main thing that I want to show you is what happens if you apply a relatively basic economic model to the question, where will we do economic activity in the solar system? So I'm going to jump over these two because essentially I want to talk about this one. The gravity model of international trade is basically a model which says the amount of trade that you do with a partner depends on how far you're apart. The largest chunk of that is simple geographic distance. But it's not just geographic distance. Empirical studies, for example, on cross-border trade between US states and Canadian provinces show that language differences matter. So places that are at the same distance, say, to Quebec as they are to another area of Canada might have different trade levels due to language differences and other differences. Borders make a difference. They add to distance. So the concept of distance in this model is not just geographic distance. But that means that it's interesting to ask ourselves for the solar system, suppose we would say this is a model. Suppose we would say, and again, it's of course an assumption, suppose we would say trade flows between different parts in the solar system will probably depend on their distance from each other. How could we turn that into something that says something about which parts of the solar system will actually be economically productive? Well, if you would say economic growth is probably very dependent on how much potential trade you have. Said slightly differently, a bit more jargony. If economic growth is, say, proportional to marginal trade flows, so the marginal propensity for trade flows, then you actually get a oversimplified model, of course, but a model which suggests which places in the solar system might actually be the places where economic activity concentrates. Then all you need is a distance measure. And for this talk, I thought I want to show you some numbers, some results. So let me just take the simplest distance measure that I could come up with, and that would be delta V. How much effort, you might say, does it take you to get from one place to the other? Is that a sensible measure? Probably not, because there are probably lots of other factors that play a role as well. So this is more the starting point for an actual project of investigation than the end, than the answer. So I will look at two sort of parts, subparts of the solar system, the Earth-Moon system and the Earth-Moon-Mars system, and I've done that calculation. So the calculation to find out what would be the economic centers of these systems. And when you do it for the Earth-Moon system with these potential, say, 9 locations, then you get the interesting results that essentially all the economic activity is apparently taking place in orbits. Which in a sense makes sense because the orbits tend to be closer to each other than those planets deep in the gravity well, whether it's the Moon or the Earth, than they are to orbits. The other model is the Earth-Moon-Mars system. And there something interesting happens. there's one parameter in this model which tells you a little bit, say, which models how punishing distance is. If beta is 1, then you might say close distances, that's an advantage. Far distances, that's a disadvantage. If beta is smaller than 1, then close distances are not as advantageous as you would think. Large distances are not as detrimental as you would think. If beta is larger than 1, it's the opposite. In this case, what you see is that depending on how this trade depends exactly on this delta phi distance, that you get different outcomes. In one case, you get an outcome where economic activity would concentrate itself in low Earth orbit, in the geostationary transfer orbit, and in the low lunar orbits. So you might say an Earth system focused, say, economic activity. Earth, the center of that solar system economy, that tiny part of the solar system. If, however, you shift that parameter a little bit, then it suddenly becomes the Mars sector, which becomes the more relevant one.
Do you assume aerobraking, yes or no, in these calculations? Are you assuming aerobraking in these calculations?
No, and the reason why not is basically because, although that definitely is something that you would want to include in this delta phi estimate, at the same time, I'm expecting these estimates to be so far off that there will be lots of other corrections that need to go in there as well. So this is more a methodological starting point and not so much a finite result. But I think what it indicates, and that I think could actually be not too far from the truth, that it might very well be that the main centers of industrial activity are not on planet. And so based on this, and with all the ifs and buts and the messy aspects of the models like this, let me speculate a little bit. What would a solar system economy look like if you would believe a calculation like this? Well, one thing it would be that capital-intensive goods production would happen off-planet, because that makes it easiest to transport it around. And actually, I must say, it doesn't sound like a bad idea. Every time I sort of visit my daughter in Shanghai, I think, yeah, maybe some of this production elsewhere wouldn't be a bad idea. Planets, however, have as an absolute sort of winning service that they can deliver environmental services. They can be a great place to visit, and say living services. They're great places to live. Raw materials, as also was concluded in the previous talk, bringing it up from planets is probably simply a bad idea. But bringing it up from everything which has a shallow gravity well is a good idea. Unfortunately, these things are around, and they are closely connected to this network. So if we include more orbits, that's of course the thing here, that's one important restriction, then probably those will come up as centers of economic activity as well. So how would that work? Does that mean that if I have to go to work in the morning, I have to take one of Elon's starships to get to work and then come back at 6 and watch the evening news? Or would it perhaps be the case that I would only work a couple of weeks a year, and that I would spend most of my time living on Earth and being a tourist on Mars, or living on Mars and being a tourist on Earth? That, of course, would only work if I could actually afford to live off just a couple of weeks of work a year. So that would mean that the, say, productivity gain from technological innovation, making labor more productive, would have to go, at least partially, to those providing the labor, and not just to those providing the capital. So there are a number of things in here where I think what it indicates is if you move to a solar system economy in the extreme long run, this won't happen tomorrow, then probably we have to rethink some of the things of our, say, of our Earth-based economic system as well. How do we discount future benefits and future costs? How do we distribute the fruits of technological innovation? That's essentially what I wanted to say. Are there any questions? Yeah.
Yes. Has there been any research done on how future discounting alters subjectively as the person in question age dependent. Do 90-year-old men have different future discounting? And is there an inflection point after which they start realizing that what they want to affect in the world is not something that will redound to their personal pleasure, but will make their grandchildren's lives better? Have they researched that?
I wouldn't be able to say whether, or say with definite certainty whether there is or there isn't. But as far as I know, it's actually something which is in active research. Because especially sort of this cross-generational aspect is incredibly important.
Right.
Because it's very important for, say, things like space exploration and the future value of these things, as well as for, say, climate change. But it is also sort of methodologically, it is actually something different. Whether you value the life of your child or grandchild or great-grandchild.
Right.
And it connects to one of these market failures that these agents, these children, they are not part of the system of the market. So the prices that we agree with one another about, say, what price is a good price to pay for going to Mars, or what price is a good price to pay for sequestering some carbon, those people who are most to benefit from this are not in our price negotiation.
It reminds me of Jefferson's comment that every democracy still has a slave class called our descendants.
So it means we have to find a way, for several reasons, not just for space exploration, but also for space exploration. I think we have to find a way of fixing that hole in our economic sort of system. Yeah.
Going back to your 100-year timeline for economic models, is the speed of the craft making the trip a factor that changed our economics, or was that?
I would say definitely when you would go down to the level of what products are being traded. Sometimes I also sort of say to my students that you, in a sense, have to imagine a world where China, the US, and the EU are on ellipses and are never sort of at a fixed distance from one another. And so I use delta V, but that is probably an extremely sort of coarse.
I guess what I'm asking is, do you see delta V getting faster? Instead of a 0.9 travel time, do you see it being a 9.2 travel time?
I could very well imagine that delta V at some point, say once, for example, energetic resources in the solar system are more exploited, that it becomes less of an issue, that travel time becomes much more important.
Cool, thanks. So does your model currently treat all delta V as equivalent?
At the moment, it just looks at the number,
Okay.
and it doesn't do anything else.
I believe what you will find is your conclusions will become what they are and more so once you account for the fact that 1.7 kilometers per second from one asteroid to another is entirely different than 1.7 kilometers per second launching from the moon to cislunar space, because you can affect that with solar electric propulsion instead of chemicals. So if you include an approximation like that, I think you'll find your conclusions are accurate and then more so.
I mean, definitely one thing which I would hope to do in the future is to actually sort of make this type of an assumption more realistic by including more of these kinds of components.
So, great talk. I think you got some really interesting conclusions there. Although I'm curious how you came to the. If you could talk more about the idea that people are going to work less, because I don't think that we've seen in the modern economy that having more money or a higher income leads to working less. In fact, in many cases, quite the opposite.
Yes and no. I would say that I would definitely not say that if say tomorrow my employer comes to me and says, Frank, how about we give you 25% more salary, that I would say, oh, that's good, then I'll work a little bit less. But if you look at sort of the broader trends, and then I would almost say particularly Europe, then from say the early times of the 20th century till now, you see a slow but gradual sort of reduction in amount of time worked. And part of that is paid for by increased labor productivity. And you see a country like the United Kingdom struggling a little bit because their labor productivity is lagging. Whereas, say, in France, in a typical hour worked, the average worker is more productive than in the UK, and in a sense, the French worker can afford to take more time off. But of course, these are, say, political choices that you make in a society. And it's very likely that there will be societies where there is, for example, a very strong moral sort of ban on leisure time, and where it's simply, that would not necessarily sound like the alternative to go for.
model approach and how sustaining a lot of these economies may be around those models. Is it logical to think that you could estimate the number of planet states that will self-organize around those economies?
I mean, the main idea essentially behind this is saying, just think of these different economies as self-organized systems. And that would actually also make much more likely that there would be trade between them. And then I would almost say trade would even be more likely in that case than when there is some central economy like the Earth who just wants to get stuff from other places.
Right.
Yeah.
Do you think about property rights of citizens?
Yes, I do think that is another reason why it's actually quite likely that these different economic centers will have their own legal say, systems and their own law enforcement. And there, of course, must be some form of coordination. But I don't think it's feasible in the solar system that from one place in the solar system you would actually control everything, legally or
They
otherwise.
propose illegal system.
So you will have different IPs.
Yes. My university and work.
Ah, yeah. One more?
Yes. So the beta factor that you mentioned, is that for individual goods, or does the market kind of assume a collection of goods?
These models are typically applied to both, say, services and goods. Obviously, if you would want
Well,
to
but
have...
I mean like an individual specific good, so like blueberries or like all
No,
fruit
so
goods?
this trade model, for example, is typically used as a model to estimate the total trade flow between countries.
Wait, do they ever
But
get
that-
more granular? Do they ever get more granular? Do people ever look at it from like an individual goods or like substitute goods perspective?
Sure, but that will of course be a different study.